Hi, I'm Tsukuharu. As someone who makes products with 3D printers, I've spent 3.5 years testing over 20 types of filaments, and even built my own tensile testing machine. Today I'll share the conclusions, backed by real data. We'll fact-check common assumptions like carbon-infused is the strongest, or PC is unmatched for heat resistance, using actual measurements. Here's the spoiler. For functional parts that need decent strength, I recommend QIDI PETG-Tough. With a heated chamber printer, you can boost the strength even more. Let me walk you through why. Honestly, until a few years ago, I believed Prusa PCCF was the best material out there. It outperforms everything in bending stiffness, and the surface finish feels premium. It was actually fantastic for making folding phone stands. But 4 key realizations led me to step away from PCCF. First, while developing the VeloFit mirror, I was sanding many small parts by hand and noticed my fingertips kept itching. Second, more YouTube channels have been raising safety concerns about carbon fiber filaments. Check the links in the description if you're curious. Third, when I ran tensile tests, PCCF turned out to have nearly identical interlayer strength to plain PC blend without carbon. Fourth, price and availability. PCCF costs 3 times more per kilogram than standard PETG, with a 2-week lead time. These 4 reasons made me drop PCCF as my main material. Up until then, I was making all these calls purely by feel. I'd bend or snap a prototype and judge if it was strong or weak. That worked for a while, but when I switched from PCCF back to regular PC, I couldn't tell which one was stronger anymore. PC versus PCCF. Feel alone wasn't enough. If I don't put numbers to this, I'll just keep repeating the same mistakes. That hit me hard, so I decided to build my own tensile tester. Commercial grade machines are pricey, hard to justify. I didn't need lab-level accuracy, just enough for relative comparison. I found a design online that fits on a workbench and put one together. Total cost, under $200. Digital force gauge, electric linear actuator, aluminum frame, all sourced from Amazon and Misumi. For 3D printing comparisons, this is more than enough. So far, I've only talked about tensile strength, but strength actually splits into very different metrics: tensile, bending, and impact resistance. For sellable products, bending strength and stiffness often matter more. In that case, PCCF makes a comeback. Looking at Prusament's official datasheet, PCCF's bending numbers, shown on screen, significantly exceed PC blend. They were nearly identical in tensile, but bending tells a completely different story. This is why PCCF was the king for folding phone stands. So in tensile strength, PCCF is average, but in bending strength and stiffness, PCCF is top tier. Carbon infused equals strong is too simple. Pick based on use case. That's the real answer. So why is QIDI PETG-Tough running on a heated chamber printer? My final pick. 4 reasons. First, even at 100% fan speed, the strength barely drops. Unusual ease of use. Normal PETG loses interlayer bonding when you crank the fan, but QIDI PETG-Tough holds up. You get print quality and strength at the same time. Second, wide tolerance for temperature and speed settings. You don't have to dial in tight settings to get strong parts. For production runs, this stability is the most important thing. Third, extra strength, boost from heated chamber. With machines like the QIDI Plus4 or the Prusa Core 1, interlayer bonding strengthens further. In my tests, that gave 15 to 20% extra tensile strength compared to a standard setup. Fourth, price and availability. Reasonable pricing per kilogram on Amazon. Lead time of just a few days. Easy inventory management. For these 4 reasons, QIDI PETG-Tough wins. And it still performs great on open frame 3D printers too. Earlier I said PCCF doesn't fit product sales, but I won't write it off completely. For bending stiffness, PCCF stands alone. The issue is, it doesn't match the use case of selling products in volume. PCCF works well for three things. 1. Jigs and one-offs. Not handled repeatedly, so health risks stay limited. 2. Stiffness-critical structural parts. When you can't tolerate bending or flex, PCCF is unmatched. 3. Parts for your own use. If you're handling it yourself, with full responsibility, it's a valid choice. Something I want to try next: hybrid printing. Using multi-nozzle printers like the Bamboo X2D or IDEX, with carbon material at the core and carbon-free material on the outside. That way, you get the stiffness with minimal health risk. Once I have results, I'll share them. Here's the filament selection chart on screen. Quick summary. When in doubt, QIDI PETG-Tough. For heat resistance, Prusa PC Blend. For maximum stiffness, PCCF. For prototyping, Elegoo PLA. That covers most use cases. For functional parts that need a certain level of strength, QIDI PETG-Tough is my pick. That's my current conclusion, drawn from 3.5 years of trial and error and tests on over 20 filaments. One more thing. Don't trust feel alone. Numbers matter. You don't need to buy a commercial tensile tester. You can build one for under $200 today. When you look at the numbers, the gap between common belief and facts becomes obvious. And when you see that gap, you can really start choosing the right material. Filament selection is a big part of working with 3D printers. Make data-driven decisions for yourself. Today, I shared about filaments. Results can change based on your 3D printer and print settings, so treat this as a reference. Hope this video helps anyone who makes things with 3D printers or struggles with filament choice. If there's a filament you'd like me to test next, drop it in the comments. Thanks for watching. Please like and subscribe. I'll keep posting 3D printing content like this. Coming up, I'm planning to share the development stories behind my original road bike pots, the design tips and tricks I've picked up along the way, and other practical lessons from working with 3D printers every day. If there's something specific you'd like me to cover, drop it in the comments. And if this helped you, subscribe so you don't miss the next one. Thanks for watching.